Hi, so today we've got this brand new Rohde Schwarz RTB2004. Rohde Schwarz did supply this to me for review and to keep afterwards, but I think most of you know that I'm not going to sort of say something I don't believe just because someone gives me a free scope. I've had a very quick play with this for a couple of hours. I'm going to do just a few very quick impressions and tear down now, and then go into more depth because there's a lot of stuff to go into on this scope. There's quite a lot of features that I've not seen on any other scope at all. A few things I like, one or two things I don't particularly like. As you can see, it's got a nice, the real headline things is firstly it's got a 10-bit A to D converter, and just from some very brief sort of playing around that, that is actually quite noticeable in terms of level of detail on the waveforms. You've got this nice big 10-inch touchscreen. It is shiny though. Some of the other scopes, like for example the key sights, have got a glass anti-reflective screen, even on the 1000. But say this is a shiny screen, so you do need to be a bit careful about how you position it on the bench in terms of light sources. General responsiveness and user interface is, it's not perfect. I don't think anything is slow enough to be annoying. You've got sort of touch screen things so you can grab waveforms, move them about quite nicely, and you've got sort of, unfortunately, although it's got the pinch gestures, because of the vertical orientation, it's not a very natural sort of hand orientation, which is, that's really a problem that's inherent in any touch screen that you put vertically. So sometimes it's actually, more convenient to do it by hand, unless, I mean, with practice you could probably start doing a sort of two-finger thing, but it depends partly on where your hand angle is and where it is on the bench, just how convenient that is. There's various menus which I won't go into details now. There's basically the menus, from what I can sort of see so far, is the menus basically let you get all the possible functionality, and the buttons give you some shortcuts into certain aspects. They'll take you straight into a sub-menu, but there are a few things where there's sort of multiple ways of doing things, so I think this is going to take just a little bit of getting used to, in that most of the functions you want fairly quickly are available on buttons, but sometimes you press the button, you think, well, where's that function I want, and it's actually in the menu that the button's a shortcut for. But I think that's really just a matter of sort of familiarity. Now the obvious thing is it doesn't have vertical controls per connector. Now obviously a lot of people are going to hate that, but there's a few things they've done to try and sort of mitigate that as an issue. Firstly, they've got a separate colour LED for each button. When you press a button to adjust the channel, these rings around the controls actually change colour to represent it, so that, for example, if you want to adjust the yellow trace, our buttons turn yellow. Doing it this way does actually have some advantages, in that, for example, it means that things other than these traces can also make use of these vertical controls. So for example, the protocol decode, if I select that, I can actually adjust both the height and the position of the bus decode, which is something, certainly position, for example the key sight just puts the bus always at the bottom of the screen, so that's quite handy to actually be able to adjust that position. Similarly, the logic channels as well, again, they share the vertical control, so we can, for example, change the spacing to adjust the vertical height, and again the vertical position. Some of these colours start looking slightly similar, so the logic is a blue, whereas channel 4 is a sort of pale magenta, and the protocol is white. So if you've got everything on screen, the colours could get a little bit confusing, but it means that you do have some consistency in that these are always vertical controls, and they apply not just to channels 1 to 4, but also the logic channels and the protocol decodes. One sort of saving thing for not having the controls per channel. Of course, it also allows more space for buttons, so that instead of things being buried into menus, there's quite a lot of direct access buttons to go straight to the thing you want. And of course, the other thing, you've got the touch screen as well. So in terms of things like vertical position, you can just touch the screen, drag it to where you want. So you've got the wide controls, that you do have that additional functionality, and you can do it via the touch screen. So I think the combination of the colouring of the rings and that does go some way to mitigate the lack of per channel controls, but obviously that's a personal preference. One other unusual thing this has got, it's got a 1 gigabit Ethernet. Now you might think, well, why am I mentioning that so soon in the thing? Well, let me show you. If you go to the web interface, so this is just a standard web browser, no special software. There's a couple of interesting things. So if I click on live screen, we have a real-time live display of the screen. Now this is intended for things like, for example, teaching applications where you'd want to show the display on a projector or maybe record the output. But as well as a live screen display, you also have a remote front panel, which again is very responsive. So yeah, this is really almost like having the scope right in front of you. So you can adjust all the settings. So you've got, you know, remote access at pretty much as fast and responsive as the scope front panel from any web browser, which is, you know, for some applications that'll be, yeah, absolutely brilliant. You know, you don't have to install any special software, just one web interface and bang, you're in. A pretty unique feature, and I'm sure some people will find that very useful. And of course, this also means that you can access it from a phone. So again, we've got the this is going through, you know, through Wi-Fi through to the network interface on the phone. And again, you've got the phone screen is a bit limiting. So for example, it can be a little bit hard to sort of tweak the knobs here, but you know, you can do the pick stuff up and move stuff around. This is quite a small small screen phone. So but yeah, it does work. It's, you know, reasonably responsive. The phone's obviously a little bit more sluggish because it's going through Wi-Fi, but it means you've got, you know, pretty much, you know, controlling viewing from anywhere straight out of the box, which is really nice. And the network interface is included as standard on this. And in fact, with the live screen display, the documentation actually mentions doing this on a Raspberry Pi. So if you just want like an HDMI output, you could just plug a Raspberry Pi in with a web browser and just get that straight away for, you know, very little cost. And the other rather interesting thing is the intensity graded display can do very, very pretty colours. So as well as the default intensity graded display, we can have rainbow, fire, temperature, which I'm sure will be useful in some circumstances. The other interesting thing, which I will go into detail and actually do some tests with because it looks quite interesting, you can invert the intensity so that the less frequent events come up brighter. So for things like looking at short duration pulses, that might be interesting, but I'll have a play around with that at some point. And also the other unusual thing which I've never seen on the scope is you can actually adjust the brightness of the front panel LEDs. At 100%, the front panel LEDs are a little bit sort of too in your face, so the fact that you can turn them down is quite useful. Now, the one thing that struck me fairly immediately that I really don't like, again this is a personal preference thing, is that the position controls and the sort of general purpose adjustment control which uses various things, these are actually detented and not sort of freely rotating, because it's the sort of thing, you know, you're quite used to, like just spinning and with your finger. I really, you know, it's traditional to have the sort of the scale and the vertical things detented, but to have basically everything detented, I think just doesn't really feel right, and I think it maybe perhaps loses some of the precision. You know, with a non-detented control with good velocity sensing, you can actually get a wider range of control. But again, some of that is compensated. For example, if you're trying to get an exact value, you've always got the option of just typing it in on screen. So that's less of a problem than it would be if we didn't have the touchscreen. But I think I can't really think of a good reason to actually use detented controls on there. So that's something I don't really like. It's got 16-channel MSO capability as an option, and that uses these external probes. So there's a sort of set of probes, then about a metre or so of ribbon cable, which is it's fairly flexible ribbon cable, and it's in 2 groups of 8. So if you're only using 8 channels, it means you haven't got another cable cluttering up the bench. Unusually for a 4-channel scope, it has got an external trigger in. Now this came with this little condom over here. I don't know whether that's fitted as standard to this or all of them, but because one issue is if you've got presented with 5 channels, it's quite easy to just sort of almost by instinct just go to that as channel 1. So maybe they just put this over this one just to reduce the chances of you doing that. I don't know. And the aux out, this is the output for the waveform generator as well as 10 meg reference and trigger out. The other thing on the front panel are these pattern generate outputs. One's used for probe compensation, and the other is a sort of extension of the arbitrary waveform generation. Again, I'll look into more detail about what you can do with these, but these are clearly designed for training waveforms, so you can put your probes onto it, which is, I think it's a bit of a lost opportunity. If they'd have put like a connector on there, the ability to actually generate logic signals out for testing your sort of system, I think would have actually been really useful, even if they're just fixed to say 3.3 volt fixed logic levels. But the fact they've used these little hooks makes them quite difficult to connect to, so that's maybe a bit less useful than it otherwise might have been. It does have a fan, but it's very quiet, and you can probably hear a little bit of fan noise, but I've got like my RF gen and ARB gen and stuff running, but probably about the quietest fan cooled instrument I've got here, so I don't think anyone would really complain about the level of fan noise. It is very, very quiet, so I don't think that's anything to be concerned about. That's it just for the very quick rundown. So I'm going to spend some time actually sort of going through it all in detail, but that'll be another video. So I think let's just take a look, general sort of look around, and then see what's inside, I think. Now the power switch, it is a soft power switch. On the back there is actually a proper mains on-off switch that isolates the supply, so that, that's okay if you can reach round to it, but when it's in this standby mode it's drawing about 7 watts according to my plug-in thing, which may or may not be accurate at that low level. Boot up time is very quick, so if I just turn it on the front panel, so that's under 10 seconds, so that's really good. I'll just see if that's any different from a cold power up from mains. Okay, so turn the mains on, press the button. No, so it's clearly, it's the same. It's not like it's cheating and using some sort of standby mode. It is, yeah, under 10-second power up, which is probably about the fastest I've seen on any scope of this sort of level, which is good. Now taking a look around the back, it's got pretty much what you'd expect. So the mains input with an on-off switch, Ethernet and USB. Annoyingly, they haven't put these in this recessed part, so if you've got it right hard up against the wall, this might actually limit how close you can get to the wall. It does have these bumpers, so this serves both as a vertical foot, but also, you know, if you're pushing it back, it means it does sort of give you a little bit of space. But possibly, you know, and if you really wanted to be tight up against the wall, you could get like a right-angled Ethernet and USB leads if you really wanted to do that. And so it's got this bumper, and also it's got these spacers, so as well as spacing it off the wall, it means, you know, it maintains the ventilation, but also means that you can put it on the ground if you run out of bench space. Sometimes it's good to, you know, just stick the scope on the floor if you haven't got anywhere else to put it. Obviously it's got these the normal little flappy bits. One minor issue with this mains thing is if you did want to run it sort of flat against the wall or on the floor, the main socket is orientated the right way for a right angle mains lead. The problem is, certainly in the UK, they actually give you a straight lead with it, which is just a little silly little detail that, you know, they really should have just given a right angle plug. I can't imagine it costs any more, so that's a minor little thing they could have done slightly better. There's this unused socket. I'm guessing this is probably the same case they use for other products. So in other products this is probably an option, but we'll see if there's anything behind there. But I suspect there probably isn't. If you look through the back here, you can see the sort of the fan down here. These holes are actually quite big, and sort of someone's commented that, you know, where they live they get quite a lot of creepy crawlies and bugs. So, you know, things could get in there, and things could potentially also sort of get in there if they get dropped at a slight angle. Also, this does feel a little bit sort of slightly more springy than I'd have liked. You know, if that got pushed against something and there's something in there, it's conceivable you could actually crack that. Sort of plenty of vent holes on either side, so yeah, there's clearly good airflow. One thing that is interesting is there's, you know, this whole top section looks pretty empty. It's almost, you know, a pity they could maybe have perhaps used that space for a built-in probe compartment, because it's otherwise sort of slightly wasted space. Overall, it's, you know, sort of fairly standard sort of size for this type of scope. It's, yeah, just the plastic feel just feels slightly sort of thinner than you might sort of expect, so it's got a bit of a tappy feel. This is a bit of a fingerprint magnet, this screen, so I think you need to sort of keep a cleaning cloth by it if you're using the touch screen a lot. I'm not sure, again, I've not used it enough to know whether you can use everything without having to use the touch screen at all. Certainly some things seem to be easier to find, but it may well be possible to navigate through without it. I haven't really tried yet, but certainly if you compare this screen to the one, for example, on the Keysight, this has got quite a nice sort of anti-reflection coating. But the thing also I've noticed on my 3104T, which is touchscreen operated, that I don't know how they do it, but that seems remarkably good at hiding fingerprints. I don't think I've ever cleaned the screen. I've been using it for quite a long time, and I just don't notice any fingerprints. So I'm not totally sure if this front is glass or plastic, so it is a bit too shiny. Now what you actually get in the box, there's a getting started guide, which is all generally all just the approvals and just all the safety nonsense, like risk of injury if you drop it or anything, all the usual safety nonsense. For the MSO, if you get the MSO version, you get 2 of these logic pods, which are 8 channels each. You get a bag of the fairly standard sort of grabbers, sort of spring hook grabbers, and ground leads, and the sort of stick on the probe inputs here. And it comes with these 300 megahertz probes. These are sort of Rohde Schwarz branded, fairly flexible cable, sort of quite a nice sort of feel to it. It is a ×1 ×10 switchable, which I'm not a huge fan of, but at least the switch is nice and bright and really obvious, so you notice it's there, and it's, I think that's stiff enough that you'd struggle to activate that accidentally. The rest of the probe is pretty much standard. And unusually they also include a spare tip. This just unscrews. That's quite convenient. And this is the sort of reason why it's nice to have a little probe compartment just to stick all the little bits like this into, because these things, you know, very easily get lost and just when you need them. So it's quite nice just to have a little compartment to shove all these little bits into. Sort of got grounding part there, plug-in, grounding lead there, and just the usual spring hook, so nothing special. It's just a pretty standard scope probe. One thing I did notice, I don't know if this is, I mean, it looks like these have got production labels, but it's possible this might not be a full production unit, but I can't see any indication saying where it's made. I don't know if that's actually a legal requirement anymore in any countries, but it's quite unusual to find somewhere that doesn't actually tell you where it was made. The other thing you've got here is the 2 fairly standard security lock thing. I think that's a Kensington lock. There's this loop which is really not that secure. I mean, I think you could just snap that off quite easily. It just doesn't really seem to have any strength. There's no metal or in there, so I think that's fairly pointless. And on the bottom there's a calibration seal. Looks like there's 2 screws there, a couple in the back and a couple at the top. So let's go. Okay, so this aluminium, this thing does actually feel quite light, but it looks like that's because they've used aluminium rather than steel for the internal parts. Got the fan mounted in here, that's sort of obviously putting air through here and then out through the power supply. You can see the front board there with the battery, and on the bottom a surprisingly small main board. It looks like pretty much everything is on this bottom PCB. So we've got looks like a shielded connector probably to the display there, a few odd bits and pieces, memory, a few connectors which I'm sure will be sort of JTAG and debug connectors on there, shielded input section. So we've got the front end shield here that's sort of screwed down to the, looks like it's a fairly solid block that the BNCs are mounted into. And this is also just clipped onto the PCB. So we can't really see much going on there. So there's not that much on this side of the board. There's ADCMP 562, that's an ECL comparator, so that's going to be for the trigger input via stitch differential lines going up here to the A to D, and then it's a custom 10-bit ADC, so it's a Rohde Schwarz custom designed ADC. Then we've got this device here, which is, I'm guessing, is probably an FPGA. I would have thought if Rohde Schwarz had done their own custom ASIC, they'd be shouting about it in the product brochure, and they're not, so I think that's probably going to be an FPGA. There's a reference in there, open source statements to some Altera IP, so that's probably going to be an Altera FPGA. And there's some memory chips down here. These are Micron 2 gigabit DDR3 SD RAMs, so that's going to be probably the main acquisition memory. There's another one over here that could perhaps be the display memory, or perhaps part of that. It just seems to be a bit far away, so that looks more associated with the, what I'm guessing is the processor over here, just looking at the overall layout. We've got the Ethernet PHY, Ethernet magnetics up here, and over here it looks like there's a JTAG connector. There's a couple of connectors down here, which again are probably debug connectors of some sort, probably FPGA, JTAG. You can just see some devices here. These are behind the logic input, so these may well just be protection diodes for those logic inputs, anti-static protection. Not really anything else of any interest on this side of the board, so it looks like we're going to have to take this a little bit more apart. I should see on the top here we've got an FFC cable going up to the front board. We've got the fan connector. It looks like the fan is actually monitored. There's some test points marked sort of fan monitor, so that's quite good. I think that's probably the output from the power supply, and there's this other one that goes over here, which is the line trigger. So it looks like they've maybe got an input board with perhaps an opto-isolator to produce a line trigger output. Incidentally, these are quite neat little connectors. These are made by Wago. They're a surface mount connector. They're quite a handy way of getting odd wires onto a PCB. You just sort of push these down and release it. So you push it down, insert the wire, then it sort of retains it quite well. So they're quite nice, neat little connectors. If you've got an all surface mount board and don't use terminal blocks, they're quite a neat solution. A slightly annoying number of different length screws in this thing, so I've just sort of labelled all these as they come out, so they go back in the right place. It looks like this PCB, having taken all the screws out, lifts out. Yep. Okay, so to the top side of this PCB, you've got the input stages under what look like copper shielding cans, which is quite interesting. Just wonder why they would do that. I mean, these are 1 millivolt per div inputs, and they're not bandwidth limited, so perhaps there is some issue there. But that I don't think I've ever seen that used before, and it's not like they're all. This one on the trigger input is the normal sort of tin plate type materials. Take an overview. We've got the A to D here. This is almost certainly an FPGA. And this, it's either a processor or another FPGA. I mean, these heat sinks are pretty well stuck on, so no real way of knowing. There was mention in some of the info I saw, which sort of implied there might be an Altera sort of processor IP implemented in the FPGA, but it's a bit hard to tell really. The one thing I did notice, there's things like the USB has external transceivers, as does the Ethernet. Maybe they're not using something that's got all that stuff on board, and perhaps doing it all in FPGA, but a bit difficult to tell really. The other thing I noticed here, there's a footprint for a battery connector, like a coin cell holder, but they mounted that on the front board, maybe just for easier access, but perhaps this was just an option for maybe a different model where they didn't want to put it on the front board. Now, the one thing that's notably absent from here is the big cluster of sort of inductors and capacitors for sort of all the power supply stuff. Most scope boards, a good proportion of the PCB is taken up with power supply, but what they're doing on here, they're actually using these little local DC to DC converters with built-in inductors. These are Empyrean, now Altera devices. So this thing here, which is I think about 12 mil square, that's a 15 amp output DC-DC converter. There's another one of those down here, but there's also, in fact, there's another slightly smaller one here, but there's also quite a lot of much smaller converters. For example, here, these are made by MPS, Micropower Systems. These are NPM 3630 and 3620. There's about 8 of these on the board overall. And these are actually 24 volt in 2 amp out DC-DC. So, and these are just tiny. For 2 amps out, it's probably only like a couple of volts, but very impressive piece of packaging. Of course, by making them small like that, they can use higher frequencies and therefore smaller inductors, by sort of coupling the inductor and the electronics very, very close together, and these may well work at many megahertz. So it means that they can be packaged into a very small little package. So they're about they're a bit thicker than an IC, but it's a very impressive bit of tech. And the BNC connectors, they're actually soldered into slots on the PCB. So there's a fairly decent amount of solder, and every BNC has got a mounting screw really close to it. So these are pretty solid. I'm sure if you whack these hard enough, you might crack it off the PCB, but I think you'd probably have to try quite hard to do that. Look at this in detail. Okay, down here we've got some 4094 just CMOS shift registers. That's probably just I/O expansion. It's maybe producing the switching for the front end stuff. Just looking at the positioning on the board. You can see all the differential outputs from the front ends going through all this wiggly traces. Obviously they need to keep the lengths the same, so the sort of long one here, and then the one that's closest has got lots of wiggly here to balance out the propagation delay, and these are all via stitched to maintain a consistent impedance. So this is the A to D, so this is a custom Rohde Schwarz part, 10-bit A to D. Underneath there's some chips there which perhaps are differential buffers or biasing or something. I couldn't figure out what those part numbers were. And then they go to this, which I'm pretty sure that's an FPGA, probably Altera. Interesting, there's some unpopulated memory locations. There's sort of 3 there and 1 there. So whether that's to either have the option of increased memory, or possibly just to perhaps allow for the use of different size memory chips to get the same amount of memory. Again, can't really tell. These are the MSO inputs. Now the MSO, because the MSO pads have got most of the buffering, I think these are simply protection diodes, and I think the signals come in at TCL levels, and looks like some sort of termination resistors there. This is the clock generator. This is a NatSemi LMK0490, which is a PLL clock generator running at 2.5 gigahertz. And the crystals, the crystal driving it is under there, a 16 megahertz crystal. And next to it, it's got its own little linear regulator, because obviously jitter and noise is very, very important around here. So it's got its own nice, clean linear supply. There's an ADR02 voltage reference there. Quite sure what that's for. And here we've got the that's obviously the Ethernet RJ45 socket, but behind it we've got the magnetics and the PHY interface chip there. And this is a gigabit Ethernet transceiver. And next to it there's a USB 3320 USB transceiver. The fact there's a USB transceiver sort of makes me think that perhaps this maybe is an FPGA, because I sort of thought yeah, most high-end processors have onboard USB and stuff. And there's some more memory here for the main processor. These are the waveform pattern generator outputs, another one of those little DC-DCs down here. A bit more power stuff, sort of linear reg, a few more of these DC-DCs. There's an inductor there, so it's pretty discrete DC-DC. I wonder if maybe that's the display backlight supply. And down here we've got the support circuitry for the arbitrary waveform generator. There's sort of the output socket here, various sort of resistor networks, relay, and LMH6733. This is a 111 gigahertz op amp. That's obviously used as the output buffer. And there's a couple of DACs here. There's a DAC 7562, which is a 12-bit DAC, but not particularly fast one. I think that's probably used for setting offsets and the like. And then there's this DAC 3171. That's a 500 megasample per second 14-bit DAC. So that'll be used for the actual waveform. That other one, perhaps that might be used for modulation as well, I don't know. And underneath these cans, this is all pretty standard stuff. This is the trigger input. So yeah, we've got some sort of analog stuff. There's the classic opto-coupled solid-state switch for the AC/DC input coupling, and just sort of load of discretes. The trigger comparators underneath here. There's that ECL device we saw on the other side. And the main analog front ends, again, they're sort of pretty standard, what we pretty much expect to see these days. Bunch of discretes, relay, again another solid-state switch for the AC/DC switching, an LMH6518, it's a 900 megahertz variable gain amplifier, digitally controlled amplifier, and say just a few buffers and amplifiers and so on. So that's all pretty much what we've come to expect in scopes these days. So, and that's pretty much it for the main board. It's very compact, nicely laid out, no bodges or anything. What you'd expect from a major big name manufacturer like Rohde Schwarz. No, absolutely no complaints at all about that. It's a very nice bit of engineering, and so it's interesting to see those little DC-DC modules all over the place. That's obviously made a significant contribution to getting the size of this down. So they've probably got like either a 12 or a 24 volt supply on one of the power planes on this board, and then all the high current low voltage stuff is just put right next to where it's needed by the FPGA and ASD converter. And here's the power supply, and the first thing you notice is it's teeny little power supply. The second thing is this is an off-the-shelf power supply. You can buy these in DigiKey, so even the worst are the people that whine about what brand of capacitors are. If this thing dies, you can get another one from DigiKey. You know, this does use Nichicon capacitors, so it's 12 volts, 65 watts, so it's pretty small for a 65 watt power supply. Obviously it's in a nice sort of airstream. Yeah, I really can't see that anyone could have any possible complaints about that. But I'm sure someone in the comments will sort of start winning, oh no, it should have been somebody else, not XP Power, but it's fine. Seriously, it's absolutely fine. Down there, there's that's just a little PCB with the it's just got an opto isolator on it for the mains, sort of the line trigger input. So there's nothing really exciting to see there. Actually, I think that's the first time I've seen an absolute off-the-shelf power supply in a piece of test gear. Tons of space. So the all this space here is just is completely unused. So I think it might have been nice if they could have put some sort of probe compartment or something. But I suppose what you could do if you were so inclined, because that's a single voltage power supply, you could stick a nice battery pack on there to make a portable scope. Because simple, 12 volts, you literally just plug it in line with the this power cable. You could actually do it without any mods. Literally just unplug that, plug it into a little board with a nice sort of big chunk of lithiums, make a nice little go anywhere scope solution. And for all you fans, this is a Sun-On fan, which I think is a sort of mid-range. But again, if it does die, firstly, it's got the monitoring, so you'll know it's died, and secondly, it'd be a doddle to replace that if you needed to. So this is the front with the cover taken off. The front panel is a single membrane, sort of rubbery keypad. There's 4 contacts per button, so hopefully those would last reasonably well. It wouldn't die until all 4 had worn out, and I would sort of seriously hope that this will be available. I'm sure a company like Rohde Schwarz would sell this as a spare part, because obviously it's fairly easily replaceable. And obviously, there is scope for these to wear down over time. But this is pretty much the same sort of thing that pretty much everybody uses these days. And the LCD is actually mounted in it looks like a custom silicone moulding, so it's got sort of quite good shock mounting. And there's obviously the touchscreen controller on the back there somewhere. There's nothing really interesting to see. Interestingly, the LCD doesn't have a metal frame around it, which is fairly unusual for a large screen like that. But that's probably a screen from a fairly standard tablet screen, I'd imagine. I think that front is glass. And there's the main front board. There's the other little subboard that's just literally got the power button on it. Although surprisingly, it's got a few other components on there. So nothing particularly exciting on this board. An AT SAM 3S1B processor, which sounds slightly over the top for just a front panel controller. It looks like it is communicating via USB. And there's some TLC 5941 PWM LED controllers, so those will actually be driving all the front panel LEDs. So the battery's on here. I'm sure that's purely just to put it in an accessible position. Voltage regulator on there, and HC4094, which is just a shift register. It's another one of the LED drivers. Interesting though, there's a beeper on here. Now this isn't the first time I've seen a beeper in a scope. A scope that I've never heard go beep. Now what I would like, and I think would actually be quite useful, is an option on a scope to say beep when triggered. Because quite often you might set up or test setup that's designed to not trigger very often, only when there's an error condition. And it would actually be quite nice to have the option to make it sort of say beep when it triggers. But I think there's 1 or 2 other scopes I've seen that have had beepers in them that have never actually gone beep. Looks like there is some sort of test or option link on here. Whether that's designed to be soldered across or actually no, I think that's what that probably is. I'm guessing that's going to be a duplicate of the power button, perhaps, so that when you're sort of bench testing it unplugged, you can maybe short that out as an alternative to having the power button PCB plugged in. Nothing at all exciting. I did look at these encoders, so it would be quite nice to take the detents out of those detented ones, but it's a bit of a job because they're sort of fully surface mount, so you'd have to completely unsolder them before you could get anywhere inside either to replace them with a non-detented version, or to actually because it's probably just like a little ball or something sitting in a gear on the shaft. So it'd be quite nice if you could actually take those out, because I really do not like having detents on those parts for the fine controls. And of course, a lot of these LEDs on the front are RGB for the colour changing for the channel number indicators. There are a few white LEDs as well. Actually, thinking about it, I just realised that I didn't see a real-time clock crystal on the main board, so I'm pretty sure that they're also using this Atmel chip for doing the real-time clock. There's a little crystal there, which I'm sure will be the real-time clock crystal. So obviously, you know, if you've got a processor there, it would make sense to do that on here rather than doing it as a separate chip. So it's quite unusual to see this many different types and lengths of screw in this thing. There's sort of a few different lengths of these, presumably M3s. These self-tappers are going into the front panel. All the pillars in the front panel are self-tap. And these logic probes, these are very similar but not quite identical to the HMO 1202 probe that David EV-Blog took apart. The circuitry looks pretty much identical, but there's just a few minor layout differences. We've got these 4 dual ECL comparators, little Z8 micro down there. There's a few just sort of minor differences if you look at the two boards side by side, but most of the components are the same. It's got another one of these little DC-DC modules. One neat feature, these have got a LED which comes on when you enable the channels. So if I turn those off, that goes out. And obviously that's quite handy, because if you've got 2 of these on the bench sort of plugged into something, and maybe if you may perhaps plug these into the wrong connector or something, then at least you know which one that you're turning on and off. So if you're seeing, not seeing the right thing on the screen, at least you've got some sort of positive confirmation that it's that one that you're talking to, which is quite handy. Okay, so it's all back together and working. Just one other quick little demo here. This, just showing off the front end. This is a 300 megahertz sine wave at 1 millivolt RMS. So this is on the most sensitive range. This is the 1 millivolt per division. As you can see, it's pretty damn clean. Very, very impressive. I'll just take the signal out completely. That's with the, I think it's a wave, yeah, that's a waveform pretty much at full intensity. So that's just an open input on 1 millivolt per div. So it's under 1 division of noise with no bandwidth limiting. So one unusual thing about this scope, it's 1 millivolt input stages aren't that uncommon now, but most of them do bandwidth limiting at the higher end, and this one doesn't. So that's actually pretty impressive. That's in peak acquisition mode as well, so sub 1 div of noise at full sampling rate, which is extremely impressive. Hardware overview. Yeah, obviously build quality, pretty much what you'd expect from a company like Rohde Schwarz. No complaints at all about the electronics. The shiny screen, I think, if Keysight can put like a glass anti-glare, reasonably touch resistant screen on their sort of lowest end scope, I think it's really not too much to ask for something a bit less sort of glossy and shiny on this one. But how much of a problem that is really depends on what angle it happens to end up on your bench. If the lighting's fine, it just isn't a problem at all. You only notice the finger marks when you look at it at a certain angle, so that may or may not be an issue for you. Other than that, yeah, really nothing major. So these holes might be perhaps slightly on the big side if you've got creepy crawlies sort of crawling around. I think they've really missed an opportunity by not offering a battery option. Maybe they'll do that in the future, because it would be so easy to put a nice, there's plenty of space there. You could get a decent amount of runtime off a big lithium battery, and there are actually very few scopes in this class that are actually available with battery operation. I believe that's one of the reasons that Keysight continued the 6000 series for quite a long time after the rest of the range was discontinued, was purely because it had that battery option. So they've got plenty of space in there, and so if there isn't a battery option, I think they could quite easily have put like a compartment in there, because it's quite handy just to have a compartment to stick all your probes and bits and pieces in. It's just a minor sort of lost opportunity there, but other than that, it's a very nice piece of kit. What I'm going to do in terms of other reviews is there's just so much on this thing that one full review would just take forever. So what I think I'm going to do is I'm just going to focus on a few specific areas and do like a relatively short videos covering specific areas of it. So please leave something in the comments if there's anything in particular that you're interested in seeing. But overall, apart from a few minor annoyances, I think probably so far probably the biggest downside for me personally is the fact they've got detents on some of these knobs. Everything else I've sort of played around with so far, looks pretty good. There's lots of stuff that I haven't even started to look at yet. A lot of scope there. So I'll, over the next sort of few days and few weeks, I'll use it more intensively. I'll probably use this as my main bench scope for a couple of weeks just to get a feel for it. and see what comes out of that. But so for the moment, I'll call it a day for this one. Incidentally, the information on pricing and offers and so on, I'll stick down in the video description, because I'm still waiting to hear back on some information. So when it's launched, there's an extremely good offer in the US, but I don't know whether that's still available, and I'm waiting on a reply as to whether or not that's going to be available outside the US and Canada. But so look in the description. I'll update sort of current information on that as and when I hear it.